Hello guys, welcome back to our channel at Smart Edu TV. If you are new to this channel, remember to turn on the notification bell and click on the subscription button so that you never miss on an important update. For our old subscribers, thank you for trusting us. Okay, so the next we are going to look at is the equations that are associated with elastic collision. The equations that are associated with elastic collision. So the first one, or let's look at our two bodies. Let's look at two bodies, M1 and M2, moving with initial velocity U1 and U2, and they are both moving towards the positive direction. So this happened before collision, this is before collision, and after the collision. Let's see what happens after the collision. After the collision, they also move in the same direction. This is still M1, this is still what? M2. So their final velocity, let me call it V1, and here I'm calling it what? V2. Okay, so please take notes. In terms of collision, a positive direction, a direction going to the right, it means that what? I'm abducting positive. Any direction going to the right signifies positive. And any direction that is going to the left, going to the what? Left signifies what? Negative. Please let's take note of this. These are very important to understand collision. Any direction that is going to the right is generally termed as what? Positive direction. While any direction that is going to the left is generally termed as what? Negative direction. Okay? So for the first one, the conservation of what? Linear momentum. M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. The second one, the conservation of what? Kinetic energy. Half M1 U1 squared plus half M2 U2 squared should be equal to what? Half M1 V1 squared plus half M2 V2 squared. And the third one, which is what? The coefficient of recession E, which is given as what? The ratio of the velocity of separation to the velocity of approach, that is V2 minus V1 over what? U1 minus U2. Or you can still write it as V1 minus V2 over U2 minus U1. So that's what for the question of what constitution. And the fourth one is one that talks about what? Impulse. Impulse, which is the product of force and time, is given as mass multiplying change in what? Velocity, that is V minus U. V minus what? U. So these are the what? Four equations that we are going to be using to solve any problem that involves what? Collision. So these are the four equations that we are going to be using to solve any problem that involves collision. Don't forget, any arrow or any direction that is going to the right is generally termed as what? Positive, while any direction that is going to the left is generally termed as negative. So let's now see how we solve collision problem using these principles. Using this what? Principle. Example 1. Example 1. Two vehicles of masses 5 kg and 3 kg approach each other with speeds 4 meter per second and 1 meter per second respectively. If there is an elastic collision between the two bodies, obtain their final speeds. Obtain their what? Final speeds. If there is an elastic collision between the two bodies, obtain their what? Final speeds. Don't forget, in that question, they gave the condition that what? If there is an elastic collision between the two what? Bodies. Go back to the table I gave you previously. For elastic collision, it means that what? That means that what? The coefficient of rotation E equals what? 1. Take note of this. There is an elastic collision between the two what? Bodies. For elastic collision, we know that what? The value of E should be equal to what? 1. Okay? So let's now start. So before we understand this problem, we need to sketch the diagram. Two bodies or two vehicles of masses 5 kg and 3 kg. Let's assume this is the first body with mass 5 kg, and this is the second body of mass 3 kg. They approach each other. For them to approach each other, it simply means that if this is moving towards this direction, this should move towards this direction. They approach each other. They are facing each other. That's the meaning. Okay? With speed 4 meter per second. The first one is 4 meter per second, and the speed of the second body is 1 meter per second. So now, we want to obtain their final speeds. So let's assume that this happened before collision. This happens before the collision. So let's assume that after the collision, don't forget their masses still remain the same. 5 kg and 3 kg. And this is what? Don't forget this is what? Before collision, this is what? After collision. After the collision. So let's assume that they move in the same direction. Let's assume that they move in the same direction. If this direction is correct, our final answer is going to tell us. And if the direction we have adopted is wrong, our final answer is also going to tell us. Okay? So we want to obtain their final speeds. Let me call the final speed of this one to be V1, and the final speed of this one to be V2. So looking at this, their momentum before collision, and this is should be equal to their momentum after collision. Why? Because we are dealing with an elastic body. For elastic body, the total momentum before the collision must be equal to the total momentum after the collision. That is, M1 U1 plus M2 U2 should be equal to M1 V1 plus M2 V2. But look at this. Let me write the formula first. M1 U1 plus M2 U2 should be equal to M1 V1 plus M2 V2. These are our general formula for conservation of linear momentum. But now, let's go back to the arrow. For the first one, it's going towards the right. That means the direction is positive. This remains M1 U1. No problem. Let's look at the second body. The direction is Is it to the right or to the left? You will notice that the direction is going towards the left. And because of that, its own sign is going to be negative. Instead of positive, it's going to change to negative. Why? The second body is not going towards the right, rather it is going towards the left. It's going towards the left. Let's see what happens for their momentum after the collision. After the collision, we can see that both of them, we assume that both of them are also going to the right. So that means they can both be positive, no problem. So if that is the case, I can apply my values inside this formula. I'm going to have, for the first one, the mass is the mass of the first one is 5 multiplied by 4. 5 multiplied by 4. That for the first one. minus, for the second one, I'm having m2, 3, multiplied by what? 1, should be equal to, don't forget, the mass still remain the same, 5 v1 plus what? 3 v2. If I write this very well, this will give me what? 20 minus 3 should be equal to what? 5 v1 plus 3 v2. So if I write this well, I'm going to have, so let me clean this. If I write this well, I'm going to have, so my first equation there is going to give me something like this. 20 minus 3 gives us what? 17. 17 equals 5v1 plus 3v2. Let's call this equation what? 1. We've gotten the first equation from the what? From the first principle, which is the conservation of linear momentum. So the second one we are going to look at, since the equation is not talking about what? Kinetic energy, we move to the third concept, which is what? The conservation of what? The coefficient of restitution. Our coefficient of restitution is what? Is the ratio of what? Velocity of separation to velocity of what? Approach. Don't forget, our E is given as what? V2 minus V1 divided by U1 minus U2. So you can use any of the formula for what? Coefficient of restitution. So let's see what we have. Don't forget, the first mass is 5 and the second mass is what? 3. This is U1 minus U2. So our coefficient of restitution here is what? 1. Should be equal to our V2. Then we are looking for, okay, we don't know V2 yet. V2 minus V1 over our U1 minus U2. Our U1 is what? Our initial velocity for the first one is 4 minus, what of U2? Our initial velocity for the what? For the second one. Our U2 is what? 1. So our U2 is what? 1. But for the U2, you can see is what? Is negative. So minus 1. So that's what? Minus 1. Because of the direction. The direction is what? Going towards the left. So we are having minus 1. So at the end of the day, this will give us what? 4 plus 1, which is what? 5. This is what? 5. So if I cross multiply, I'm going to have V2 minus V1 equals 5. I'm going to have V2 minus V1 equals what? 5. Let's call this equation what? 2. So I've now solved equation 1 and equation 2 simultaneously so that I can get the final speeds of those colliding bodies. So by doing that, so I can what? Rearrange the equation well. If I rearrange the equation well, I'm going to have, I can write this as 3v2 plus 5v1 equals 17. 3v2 plus 5v1 equals what? 17. So let's now solve simultaneously. So to solve this, don't forget, you have to have the same what? Coefficient. You want to eliminate what? V2. So that means multiply this one by 3 and multiply the whole of this by 1. So that will give us something like this. 3v2 minus, multiply by 3, 3v1 equals 15. 5 times 3 gives us 15. For the other one, multiply everything by 1. We have 3v2 plus 5v1 equals 17 times 1 gives us what? 17. So if I what? If I solve for this, by what? By solving for what? For v2. If I change this to what? Minus. Change this to what? Minus. And also change it to what? Minus. So that this cancels this. If this cancels this, they are going to left with what? Minus 5v1 minus 3v1, which is what? Minus 8v1. Minus 8v1 equals minus 17 plus 15. That's what? Minus 2. Minus 17 plus 15 gives us what? Minus what? 2. At the end of the day, our v1 Our V1 equals 2 over 8. Our V1 equals what? 2 over what? 8. Minus cancel minus. And what is 2 over 8? 2 over 8 will give us what? My calculator. Let me find the result of 2 over 8. 0.25. 0.25 meter per seconds. So our V1 is 0.25 meter per what? Seconds. So since I've gotten the value of what? V1, I can go and substitute in any of the equation so that I can get what? V2. From equation 1. From equation 1, I can have V2 minus, what is V1? My V1 is what? 0.25 equals 5. So that V2 equals 5 plus 0.25. So if you add 5 to that answer, we are going to have our V2 to be what? 5.25 meter per what? Seconds. So these are the final speed for what? For the colliding bodies. For this V2 and this also what? V1. What do we notice? We notice that the results, they are both what? Positive. Since the results are both positive, it means they are what? In the same what? The direction that we have assumed is actually what? Correct. Had it been one of the answer is what? Is negative. Had it been one of the final result is what? Is negative. For instance, if V2, had it been V2 is what? Minus 5.25 meter per seconds. It simply means that the path we are taking is the what? Is in the reverse direction. Maybe in our what? Momentum, we have reversed what? Maybe the arrow is like this before, when we assume. And when we now solve, got the answer to be something like this. Just the answer is still correct. Just go and what? Change the direction. Just change that direction to this to show that what? The answer is actually what? 5.25 meter per what? Seconds. Why? Velocity can never be what? Negative. Thank you very much.